Hello everyone. Welcome you back for the sessions on the shape memory array, that is especially with respect to the experimental phenomenology, or it may be experimental phenomena. If the shape memory wire is through the temperature cycle starts with the wire in a fully austenite phase, that is high temperature phase. Let it is represented as the AF, which is nothing but a austenite finish, represents the temperature at which austenite is entirely convert austenite start has been converted entirely to austenite finish. Now the wire is cooled until it reaches to a temperature at which the phase transformation begin. This phase transformation is the course from fully austenite is converting into a martensite, that is at low temperature. Let m suffix s represents the temperature where the material is martensite. Upon further cooling, the martensite begins to increase until m suffix f, at which the temperature of the wire is in fully martensite phase, where it is represented by the volume fraction of the martensite as xi. Now in this slide we are explaining the two phases. One is with respect to the low temperature phase, the another one is a high temperature phase. Especially with respect to the martensite property, the entire thing is explained with respect to the low temperature phase. But with respect to the austenite, the entire thing is explained with respect to the high temperature phase. Now xi represents the volume fraction of the martensite in the material. Then at austenite finish, the martensite starts. The xi represents the volume fraction of the martensite in the material is equal to 0. Xi represents the volume fraction of the martensite in the material is equal to 0. In the same way, martensite finish at the austenite start, where the xi is represented by the volume fraction, where the martensite is equal to 1, or the volume fraction xi is equal to 1. If we know the begin to heat, the wire xi represents the volume fraction of the martensite in the material, which is equal to 1. Nothing will happen to the material phase, but the temperature increase. When the temperature reaches to a martensite phase, begins the rearrangement of themselves to a original configuration. Especially in this case, the xi value which is varying from 0 to 1, the xi value, it will be 0 at the position where austenite finish and also the martensite start. It will be, but once if it is reaches to a martensite finish and also austenite start, at that particular point the xi value, it will be 1. It means that the volume fraction, it is varying from 0 to 1, which is having a major application with respect to the damping, or it can also be used as a vibrational absorbers, or it may be something like a shock absorbers. Now, thus as represents the temperature at which the high temperature phase starts. Upon further heating, the rearrangement continues to complete to form AS, which is nothing but austenite start. The cycle is complicated and complete when the wire begins at austenite phase. The transformation at low temperature is fully martensite and reversing upon heating to the original high temperature, which is nothing but the parent phase. Thus the critical temperatures of the martensite start, martensite finish, austenite start and austenite finish with martensite, which is described as the xi values, which is varying from 0 to 1. In the schematic diagram which is shown on the right side, the above graph which is representing the graph where it gives the xi value which is varying from 0 to 1. As we know that there are two phases with respect to the temperature. One is nothing but the low temperature phase, the another one is nothing but the high temperature phase. In the case of the high temperature phase, the austenite start and as well as the austenite finish will be, but in the case of the low temperature phase, martensite start and as well as a martensite finish it will be. Once if the martensite start and as well as the austenite finish, at that particular point the xi value it is of 0, and once if it reaches to a martensite finish and as well as a austenite start, at that particular point the xi value it will be 1, which is varying from 0 to 1, which is the same thing is represented by something like a sinusoidal curve which is varying from 0 to 1 and again it is coming to 0, then again negativity is going to 1 and again the 0. This cycle it can be repeated. For that reason only this material comes under the category of the shape memory effect. Now in the further slides what we are discussing is with respect to the vibration control through the shape memory alloy. The first and foremost basic thing here what we are discussing is with respect to the preliminary test, the steel beam with a external actuation. Now the schematic diagram shows a cantilever beam. The cantilever beam is made up of a steel hollow tube which is of the cross section of 25 by 10, over which on the both the ends, fixed end and as well as at the free end, a Teflon blocks are fixed. For the Teflon blocks, the 4 wires are attached. These wires are nothing but the shape memory alloys. Once if the heating and as well as the cooling is done for the shape memory alloy, automatically the deflection of the beam will takes place. Even in the deflection of the beam also, which is nothing but the hogging is taking place at the free end. Now a specimen of a preliminary element, a low cost SMA is attached to the steel box, or it may be a steel tube which is in the form of a beam. A 4 strands of nitinol wires are mounted on the top of the horizontal cantilever beam. The wire is supported through a Teflon block which is clamped on the beam at the fixed end and as well as at the free end. The stainless steel which contains the block moves apart until the wire were taught to the room temperature, and the tension of the individual wires were adjusted by inserting a split washers. Now each nitinol wire of the beam having a diameter of 1 mm and a resistance of 1 ohms, each wire was driven by a channel of electric control system. The heating and as well as the cooling is done by using the electric control system. Now even in these materials also, the heating is a continuous process and it is a gradual process, but once if it is comes to the cooling point, the automatically even that is also a gradual process. But the cooling curve it will be a very slow process, but the heating curve it will be a very fast process. A wire was characterized by a scanning calorimeter. The following data were observed observed and as well as the austenite start temperature, austenite finish temperature, martensite start temperature and as well as a martensite finish temperatures were recorded. The austenite start temperature it will be somewhere around 38.6 degrees centigrade. Austenite finish temperature it will be somewhere around 55 degrees centigrade. The martensite start temperature it will be 27.8 degrees centigrade, and the martensite finish which is nothing but minus 1.6 degrees centigrade. The martensite finish it is at somewhere about minus 1.6 degree centigrade, which is below the room temperature. And also, to achieve the entire martensite conversion from austenite, this is done by using the cooling curve, and it has to be cooled below the room temperature to have a 100% conversion. It is clear that austenite transformation may be accomplished by heating, but the partial reversion to the martensite can be expected by cooling to the room temperature and even below it.